कि हमें क्यों कहना है?
हाँ 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 हाँ
हम तो बता चुके हैं अपनी तरफ से सारी बात। ज्वाइन किया है कुछ लोगों ने वहाँ।
किसमें सर?
मैंने बच्चों को भेजा है। इसकी ऑनलाइन में भीड़ हो रही है।
वहाँ पे भैया जान। अच्छा,
अगर करी तो देख रहा हूँ।
संजोली, संजोली कौन है? पूनम रानी।
मेरे घर में मेरी स्टूडेंट
ये अनम्यूट, अच्छा
Professor Meerchand.
आवाज जा रही है? ऐसे आएगा?
सारे बंद रहते हैं, कैसे आएगा? सारा बंद हो जाएगा। प्रोफेसर मेयरचंद.
Good morning, all of you. We will start very shortly. I am just waiting for Professor Martin. He is going to join us very shortly.
Professor Meerchand, kindly permit me to share my screen.
Yeah, sir. Sir, I will give you permission after announcing the session. I am just waiting for Professor Martin. He is going to join us very shortly.
Professor Meerchand, kindly permit me to share my screen.
Yeah, sir. Sir, I will give you permission after announcing the session. Sir, now you can share your presentation.
Okay.
Sir, now you can share your presentation. Good morning, all of you. The session of the day is going to start, and the theme of this session is innovative techniques and its applications in the field of mathematical modeling, biomathematics, and computational techniques in sciences. In this session, there will be plenary talk is given by Professor Satya Singh from Punjab University, Patiala, and there will be invited talk by Professor K. Martin Sangyam. And talk of Professor Satya Singh will be chaired by Dr. Narendra Singh. So I will invite Dr. Narendra Singh to introduce Professor Satya Singh. And
thank you, Professor.
And now you can start.
Yes, thank you, Dr. Meerchand. Now I am introducing Professor S.B. Singh. Professor Satya Singh is a professor of mathematics at Punjab University, Patiala in India. Period to this, he worked as an assistant professor in mathematics at the Thapar Institute of Engineering and Technology. He has published about 125 research papers in well-reputed journals and given innovative talks at various conferences and workshops. He has also organized several national and international conferences. He has guided 15 PhD and 8 MPhil students. He has been a coordinator and principal investigators of several schemes funded by the Departments of Science and Technology, Government of India, New Delhi, the University Grant Commissions, Government of India, New Delhi, and all the Indian Council of the Technical Educations, Government of India is New Delhi. He has 25 years of teaching and research experience. His area of interest include mechanical of composites materials, optimization techniques, and numerical analysis. He is a live members of various learn bodies. Now I am invited to Professor S.V. Singh for his lecture. Doctor, please Professor, now you can start lecture.
Thank you.
At the outset, I am thankful to Baba Farid group of colleges, Professor Meher Chand and Dr. Naren Singh for inviting me to deliver a talk in this session. I am sure that the way in which Dr. Meher Chand is organizing this conference will put a foundation for those who are willing to work in mathematical modeling, numerical techniques, optimization techniques, and artificial intelligence. Today, we will be discussing recently developed meta-heuristic algorithms. Dr. Naren has already introduced me. It is really a pride moment that Dr. Naren Singh has done PhD under my supervision, but it is a very proud moment for a supervisor that his student is chairing a session. Congrats, Dr. Narendra Singh. Now, I start my presentation. We start the presentation with the history of development of optimization. There is a effort from Cauchy that he has developed steeped descent method for minimizing a function, but it was not a formal approach for the optimization linear programming problem or nonlinear programming problem. In 1939, Kantorovich presented an algorithm, but it could not get momentum because of lot of political disturbances in USSR. But at a later stage, in 1947, Dantzig and others presented a formalized approach of linear programming, and this got lot of momentum, particularly for production planning problems during Second World War. And this method was known as simplex method. Because of this work, the work done by Kantorovich and Koopmans got momentum, got recognition, as a result of which both the workers Kantorovich and Koopmans got Nobel Prize in Economics. Nobel Prize in Economics because of the reason that there is no Nobel Prize in mathematics. You all know that why it is not given in mathematics. In 1979, Khachiyan proved a very powerful ellipsoid method, which was having polynomial time performance. But due to complexity in computations, this is not popular method for linear programming problem. There was a breakthrough in 1984 that Narendra Karmarkar presented a project scaling algorithm for LPP. This is a very powerful method for solving linear programming problems, but it is used for very large size problems. Till now, there was not a method available for solving nonlinear programming problems. In 1951, Kantakar gave necessary and sufficient conditions for solving nonlinear systems. And as a development of the subject, Bailman presented dynamic programming problem and how to solve linear and nonlinear problems. There was a significant contribution from Fiaco and McCormick in the field of nonlinear programming problem. The geometric programming was developed in 1960 by Duffin, Jenner, and Patterson. And Dantzig and Chance also contributed, not only the simplex method, they contributed towards stochastic problems, because this is a very burning topic from olden days. The concept of multi-objective programming problems, game theory, goal programming, how to solve fuzzy linear systems, fuzzy non-linear systems, was later on developed year by year. Recently, people are using nature-inspired techniques for last few decades. These are very powerful techniques, and the beauty of nature-inspired techniques is that these methods do not require basic assumptions of calculus for the given function or the function to be optimized. To start with, what is optimization? Optimization is an art of selecting the best alternatives amongst a given set of options, or the process of finding the largest or the smallest possible value which a given function can attain in its domain of operation. The function has to be optimized in a prescribed domain, which is prescribed by a number of constraints in the form of equalities or inequality. It may be equality constraint, there may be equality constraint. There is a need of robust optimization technique. The reason is that there were few methods like simplex method and project scaling algorithm developed by Karmarkar, which can guarantee to solve any type of linear programming problem. But there is a need to develop a method which can guarantee to solve all the nonlinear programming problems. Unfortunately, there is no method till date which can guarantee to solve all the all the nonlinear programming problems. But efforts are being done by the researchers to develop very powerful nature-inspired techniques which are able to solve most of the nature-inspired techniques. Therefore, there is a need to develop a robust technique, a powerful computational technique, which will form a foundation to solve all the nonlinear problems. A method in this series is particle swarm optimization. In this method, each particle is behaving like a bird because this method is based on swarm of birds or flock of birds. Therefore, each element in this space behaves like a bird in the search space. All the particles have fitness value as the word has associated a velocity and a position with it. Therefore, all the particles, since they are behaving like a word, they have a fitness value, which are evaluated by fitness function to be optimized in mathematical terms. And all the particles have velocities because every word has its velocity while searching for food. Therefore, there are two things associated with this with the word. One is velocity, other is its position. That bird changes its position while searching for the food. And likewise, if we mimic this concept in mathematically, then we generate a swarm of particles and find the fitness values for the given function. The objective is how to reach the optimal solution of the given problem using that swarm of the particles. This method, particle swarm optimization, was developed by a Canadian Everhart, One of them is social psychologist and other is electrical engineers. Think of this situation that neither of them is from mathematical discipline or the computer discipline. Though all these techniques are totally dependent on mathematical concepts and computational part. Inspired with the flock of birds or fish schooling, Canadian Everhard developed particle swarm optimization. The beauty of these method is these method particle swarm optimization can solve discontinuous, multimodal, non-convex, multi-objective problems. Swarm intelligence is based on social psychological principle and provides insight into the social behavior as well as contributing to engineering applications. There are principles of this particle swarm optimization. Proximity principle. The population should be able to carry out simple space and time computations while searching for the optimal solution. The quality principle. The population should be able to respond to quality factors. That is, the point generated in the swarm will be should be the quality points. And diverse response, the particles should respond to each other while they are moving in narrow channels. Stability, the population should not change its mode of behavior every time an environment changes. Adaptability, the population must be able to change behavior if it is needed, because if it has a very high computational price, then they can change its mode of behavior. The benefits, advantages of particle swarm optimization is these methods have faster convergence and they have very less number of parameters to tune, that you can tune some parameters to find or to do various numerical computations or various numerical experiments. This is very useful in finding solution for large size problems. This shows the locations where particle swarm optimization is being used worldwide. The movement of particle in particle swarm optimization process can be seen from this figure, that suppose we are here at the initial stage and my best performance is in the near eye proximity, and PG is the best position of my neighbor. The particle moves towards the best position in this manner. This is proximity of my best performance, and particle is moving towards the best performance of my neighbor. The position and velocity are continuously updated in this process to reach at a global optimal solution like this. At a later stage, we will also show more closely that how the particles are moving from one point to another point. There are very important two aspects in this method, that velocity update equation and position update equation. This is current velocity, this is velocity update equation, this is current velocity, and this is update velocity. We can use the computer program. There are standard programs for standard particle swarm optimizations, and people have developed a lot of computer programs in MATLAB for different variants of particle swarm optimization. The velocity update equation is V is equal to V C1R1 bracket P west minus current plus C2R2 G west minus current position. V is the updated velocity and second V is the current velocity. We can program it very easily. C1 and C2 are prescribed numbers, acceleration factors that can be used. They are prescribed predefined quantities in the computer program. And R1 and R2 are random numbers which you can use. You can use any software, you can use any function subroutine to generate these numbers between 0 and 1. This is P west the best position of a particle, and second one is the global best position, G best, that is the best position of its neighbor. This is global best position. We continuously update this using this formula, and after finding velocity update, we will modify the position of the particle. Once velocity is calculated, we will substitute the velocity in the second equation to find the position update. Current is equal to current plus V. Current means current position of the particle is equal to previous position of the particle plus velocity update. We can use different kind of suffix to program it. The basic flow of particle swarm optimization is that if a function to be optimized is given to us, then firstly, we initialize the swarm from the solution space. And once we have initiated the solution swarm, we evaluate fitness of the individual particles, because we have generated a lot of particles in the form of swarm. Swarm means lot of points, a group of points. We have generated swarm. After finding swarm, we find the functional values, which are known as fitness, in this case, fitness of individual particles. We modify G best, P best, and velocity continuously to find the, or for moving towards the optimality or the optimal solution. Move each particle to a new position, go to step 2 and repeat until convergence or a stopping condition is satisfied. Firstly, we generate a lot of particles. Secondly, we find the fitness values, and we continuously find, depending upon the sense of optimization, we continuously update velocity. After updating velocity, we update position of the particles, each particle, and find the G best and P best, personal best position and global best position of the particle in the search space. And if we talk of convergence, we can put a convergence criteria in any manner. Suppose, for example, if we are interested in putting a stopping criteria on functional value, then we can say that the absolute difference of two consecutive values of function should be less than epsilon. Epsilon is a predefined number. Say, for example, if we are interested in finding out the functional value correct up to, say, 6 decimal places, then we will say that epsilon is equal to 10 to the power minus 6. It depends upon our requirement or the type of optimization or the type of analysis we are interested in. These are algorithmic parameters that we first generate: population of agents, then position of agents. AI is the solution space. We find the fitness function using the objective functions, depending upon whether it is a single objective or multi-objective. Velocity of agents, that is, for each particle we find the velocity. This is a kind of algorithm, the same steps which we have discussed right now. And in the form of algorithm, we can write it like this, that is, initialize particle from 1 to IT max. We define a maximum number of iterations to be performed and various other parameters. But basic equations are given at last, that V is equal to V plus C1. RAND means random number, right? One random number and other random number. P is equal to P plus V means position is equal to position plus V. Once you have calculated velocity, you can continuously update the position of the particle, each particle, using this equation. P is equal to P plus V with V is equal to V plus C1 into random number, bracket P best minus P plus C2 into random number into G best minus P, where all the parameters V, C1 have usual meaning. That is, C1, C2 are predefined or pre-assigned numbers, Random number, as discussed, random number can be generated using any functional subroutine between 0 and 1. This is how we calculate position and velocity of each particle. This is what basically important part of this algorithm. That is, you have to find, you have to generate the particles, and after generating the particle, you have to find for fitness values of the particles, and you have to calculate particles position and velocity for all the swarm. There are two kinds of approaches in optimization technique. One is deterministic approach, other is probabilistic approach. Deterministic approaches are lot many. Deterministic approaches are those approaches which gives you a finite answer in certain number of steps. Suppose you are solving a problem using Golden section method, you are using a simplex method, you are using any kind of interpolation method, a stupid descent method, different kind of gradient methods. These are deterministic methods. Whereas those problems which cannot be solved using deterministic approaches, we use probabilistic approaches, stochastic approaches, random numbers, swarm intelligence, heuristic. These are different terms. These class contain genetic algorithm, random search methods, simulated annealing, ant colony optimization, taboo search, differential evolution, particle swarm optimization, memetic algorithm, artificial bee optimization, biogeographical based optimization, globome optimization, gray wolf optimization, sine cosine algorithm, mouth flame optimization, champ optimization, SALP optimization, and lot many problems. Just to make the algorithm clear, we will do an elementary example. We should make the things clear because most of the functions to be optimized are non-linear in nature, and no method can guarantee to solve those methods. The simple example is if we have to minimize function fx is equal to x1 square plus x2 square in minus 5 to 5. The x1 and x2 can vary minus 5 to 5. First, we generate the particles, a set of particles, say for example, 5 randomly generated uniform distribution in minus 5 to. You have generated a swarm of 5 points. This is swarm of 5 points. Now, after generating swarm of 5 points, this is 2.7045, this is x1, 4.8030, this is x2, and so on, others also. Out of these swarm, the minimum value in the first column is 1.64, in the corresponding point is 1.3202. Similarly, the velocity is also generated between 0 and 1. Now, the process starts. Firstly, you have generated the swarm. The second step is find the fitness vector. You have to find the fitness vector for all the generated points. That is, once you know the values of x1 and x2 for a swarm of 5 points, you find the functional values by substituting x1 and x2 in your given function, given objective function. These are the values 30.3831 and so on. Out of this, since we are interested in finding the minima of a function, therefore out of these 5 values, 4.4325 is the minimum value. Now, we proceed to next iteration using PSO update equations. For first particle and first component, velocity is v11 is equal to v11 plus c1r1, p west for 11 minus x11 plus c2r2, g west for 1 minus x1. So v11 is equal to, this is just an iterative process. This is v11. V11 is known to us. This is v11 means 0.4752. 0.4752 in the first row, plus C1, a predefined number, 2 plus random number, it has been generated through a subroutine. This is 0.24 plus personal best position. This is 2.7045. This is for first particle, first component. First particle, first component, 2.7045. We have substituted 2.7045 minus x11 because we are starting the computation, and therefore our personal best position is same as x1. Therefore, we will write 2.7045 this at this place also, plus C2. C2 is 2 plus into R2. Second number, random number generated is 0.86 into G best. G best is 1.64. This is 1.64. That is among the swarm, the minimum value of the first component is 1.64. Therefore, we will substitute 1.64 minus x11. X11 we already know that it is 7045, and we have calculated the first part, that is velocity update for first particle, first component. This is minus 1.35574. And therefore, we already know that position is equal to position plus V. We already know the value of V, and therefore update position is for first particle, first term is x11 is equal to its previous position. Already know that 2.7045 plus we have just calculated the velocity. We substitute it and we can find the x11. This x11 lies in the given range -5 to 5, and therefore this solution is acceptable. Similarly, for second component, we find V12 is equal to V12 plus C1R1, P best for 12 minus means first particle, second component. 12 means first particle, second component, minus x12 plus C2R2 into G best minus x12. We have again taken the values from V12 is equal to 0.6987. This is first in the first row, 0.6987. This is the second component of the velocity. This is second component of the velocity minus x12. This is second component. Okay, plus 2. This is the value of C1. Random number of 0.47. P best, personal best position 4. This is 4.8030. This is first particle, second component. First particle, second component. Therefore, next 4.80. Since you are initiating the process, therefore P west is the same as x12 plus C2 2 into R2, a random number, and G best, its global best position that we have discussed, this one. In second column, yellow number, that is 1.3202. This is the 1.3202 minus x12. We have already substituted 4.8030 and is equal to 5 points minus 5.63996. This is V12, that is second component of the first swarm velocity component. Again, we can modify the position, that is the first swarm second component. So x1 is equal to its previous position, which is 4.8030 plus V12 is equal to this. Again, we will check whether this number lies between minus 5 and 5. If it lies between -5 Again, we will check whether this point lies in the given range -5 to 5. It lies, and therefore we will accept it. Therefore, after first iteration, the first swarm is updated like this. That is x1, its position update is 1.34876, comma minus 0.836996. This is how we compute the process. I have clarified how to perform the computations, because if we talk in the broader sense, you cannot grasp it that how to calculate position and velocity update for a swarm. This is how we calculate. The same computation is done for second particle, same is done for third particle. Since we have taken 5 particles, this is fourth particle, fifth particle, and after the then calculating all the 5, we list them. Once we have listed them, then again find the fitness value for each updated position. Then fitness values are 2.5194, 9.5797, and so on, so on. And out of them, minima is 2.5194, and therefore at this position, clearly it can be seen the least fitness is 2.5194, which corresponds to the first particle. Therefore, G best for update swarm is x1. That is, its global best position is first particle. Global best position is first particle. We continue this process until we find an optimal solution or the approximate answer after a finite number of iterations. This is how particle move. Then the discussion which we have carried out just now is mathematical. Now we can geometrically see how the particles are moving towards the optimal solution. This is the way. This is after first iteration. This is after second iteration. This is after third iteration, and so on, so on. This is how particles are moving towards the global solution. These are very, 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 very close to global optimal solution. The advantages of the algorithm are: this is insensitive to scaling of design of variables. Its implementation is very, very simple. You can easily parallelize for concurrent processing, and you do not need various calculus based assumptions that function should be differentiable, it should be continuous, and all that, or it should convexity criteria, which are often needed in linear programming while you are discussing the geometry part. There are very few parameters you have to tune. That is, you have to tune C1, R1, or the swarm size, and other frictional factors. This algorithm is very advantageous, and it is efficient in solving the global optimization problems. The disadvantage is that is tendency to a fast and premature conversion, because suppose you are interested in finding out the global optimal solution, then sometimes it may give you a premature convergence near some other local point or local minimum. Therefore, there is need to refine the process, refine our search, so that all the local optimal solutions are removed, and we are moving towards the global optimal solution. Our group, myself, Dr. Narendra Singh, and Dr. Charandeep Singh, has developed various algorithms in particle swarm optimization. These algorithms are one half global best position, hybrid PSO, modified mean and standard PSO, personal best position, exponential cumulative distribution mean PSO, real life problem solved by MPSO, and real life which were solved by economic dispatch problem. In all these algorithms, there should be a test for the algorithm, whether it is acceptable or not. Then we have taken the benchmark problems. There are scalable and non-scalable problems. These are scalable, 15 scalable problems, 15 scalable problems. None of these problems can be solved using calculus-based methods. And these are non-scalable problems, 13 non-scalable problems. While developing the algorithm, it has been kept in the mind that after developing the algorithm, we have tested it for benchmark problems and some practical problems and compared the results with the standard particle swarm optimization or some other algorithm. This is a modified version of standard PSO, one half global best position particle swarm optimization. The velocity equation of the standard PSO has been modified in this, and the feasibility using this algorithm to achieve global minima has been tested through standard benchmark function. Performance of proposed algorithm has also been compared with SPSO in terms of convergence and accuracy. This is how we have modified the velocity update equation and the position update equation. After solving the 15 scalable and 13 non-scalable problems, we have compared the results of the algorithm with the standard PSO. These are the results for all the 28 problems. That is, for scalable problems, SPSO was best for none, and our algorithm was best on 15 problems, and SPSO was bad on 15 and it failed on one problem. Our algorithm does not fail for any problem. And non-scalable problems, it is best for 8 and bad for 3 and fail on 0. Similarly, our algorithm is best on 3 and bad on 8 and fail on 2. Aggregate, the performance is that SPSO is best on 8 and our algorithm is best on 18 and bad on 18 and our algorithm is bad on 8 and fails on 2. The summary is there is a need to develop powerful algorithms which can guarantee to solve all the 28 problems, that it does not fail on any and it does not give bad answers to the given problems. These are practical problems, 5 practical problems. The SPSO was best for none, bad for 4, failed on 1, and our algorithm was best on 4, bad on 0, and uh, equal results and for at par with the standard particle optimization on one problem. The conclusion is the proposed variant has been used to solve several benchmark problems, multi-objective, multi-model, mixed integer, constraint, and fractional functions. The result obtained has been compared with those obtained through SPSO. On the basis of numerical results, it is concluded that the SPSO performs better than the proposed algorithm if the dimension of the problem is fixed. For a variable dimension of the problem, the proposed algorithm performs much better than SPSO. Moreover, the proposed algorithm can be used to solve different kind of real life problems. This is one variant of particle swarm optimization. There is next variant of particle swarm optimization is hybrid particle swarm optimization. The next is a modified version of PSO has been proposed. The modified algorithm has been tested on several scalable and non-scalable problems. The results obtained have compared with SPSO, mean PSO, and one parameter. Just we have developed OHGB PPSO. We have compared the result of this HPSO with different algorithm. Our objective is while you are developing an algorithm for particle swarm optimization or some other nature inspired techniques, firstly you have to test that algorithm on benchmark problems available in the literature. then you can say that this algorithm is working well on these problems, different kind of optimization problems. This is how we have modified the velocity and position of the equations after this is algorithm of our method, and this is velocity update, and the parameter selection for this process is that is inertia weight has been taken from the range 0.4 to 0.9 and acceleration factors from 1.5, and this you can tune these parameters at your will. You can find different kind of, you can do different kind of numerical experiments to find a better solution. We have done a lot of experiments on these problems. The parameters which are listing is one set. Otherwise, for finding this set, we have done a lot of experiments. After that, we have listed these results. Again, the working performance of this algorithm has been tested on 28 benchmarks and for different kind of functions, multimodal, multi-objective, without constraint, with constraint, and other. The analysis SPSO and HPSO, swarm size 30, functional evaluation is 30,000, inertia weight, this acceleration coefficients, this. Again, we have compared the results obtained from this new algorithm HPSO with the other algorithms. You can see that while solving the scalable problems, our method is working best on 11 problems, whereas other methods are working best for 0 and best for 4. For non-scalable problems, you can see that out of 13 problems, our method is working well best on 10 problems, and other algorithms are working best on 0 and best on 3. That is, we have improved the previous algorithm tremendously. The total, if we compare in the previous algorithm developed by us, we were giving 7 best results. That is, our algorithm was based on 7, but the present algorithm is based on 21 out of 28 problems. That is, it is working based on 20. Most of the problems have been solved, but it is giving bad answers for 7 problems. Therefore, there is still need to develop more and more algorithms for finding the best solution on the very.
Hello. Hello, Professor SP Singh. Sir, time about to complete. Please conclude your talk.
Okay. The conclusion is there is a need to develop various algorithms. Since time is very less to discuss all the algorithms, I can just show you the slides. This is conclusions of this. Again, we have developed a modified variant of this modified mean PSO, and this is parameter. Again, we have compared the results. This is another improvement in the existing algorithms. Again, we have compared the results for all the 28 problems with the existing algorithms. This is showing the performance of these algorithms. After finding, this is another variant of particle swarm optimization, PSOE. These are steps and algorithms for this. And we have at last solved the economic dispatch problem, that how to find the solution of how to find the fuel cost of the power plant subject to the operating conditions of a power system. This we have solved. And after that, there is another variant of the particle swarm optimization. At last, we have solved several problems using different kind of we have selected best 4 algorithms and compared our best algorithm with the existing best 4, and we have found that our algorithm is working best out of those. Next variant is gray wolf. And there are different kind of particle swarm optimization in the literature. The recent nature inspired techniques are gray wolf optimizer, sine cosine optimization, mouth flame optimization, champ optimization, sharp swarm optimization, and many others. At last, I can say that there is need to develop a robust technique which can guarantee to solve most of the problems of the real life, because in the real life problems are mostly nonlinear in nature, and there is no method which can solve all the nonlinear problems using the powerful techniques. I again thank organizers for inviting me to deliver this invited talk, and thanks are due to Professor Chand, Dr. Narendra Singh for chairing this session and giving me time to present my talk. Thank you.
Thank you, Professor S.B. Singh. Now, if anyone want to ask any questions, you can ask.
Please.
Okay. Now, I am inviting our next lecture, Dr. K. Martin. Firstly, I will introduce Dr. K. Martin. Dr. K. Martin received his PhD in electronic and communications engineering, signal processing using the machine learning algorithm from Karuna University. He received Master of Engineering in Communication System from Anna University, Chennai, and received Bachelor of Engineering in Electronics and Communications from Anna University. Currently, he is working as assistant professor in departments of ECE, Karuna Institute Technology Science. He has co-authored more numbers of referred international journals. He has also presented more than 20 research paper in reputed international and national conferences. He has authored 2 edited books and 10 book chapters with international publishers like Elsewhere, Springer, IZB Global, and CRC Press. He has editorial scopes in the reputed books and book series with the reputed international publisher like IZB Global and CRC Press. He has received research article from the Journal of Signal, Images, and Video Processing, Intelligence, Decision Technologies, International Journal of Engineering, Research and Technology, Pattern Analyze, and its applications and informing science institutes. He is an active member of professional bodies such as engineering, scientific research groups, International Society of Promising Computer Engineering, Scientific Engineering Research Corporations, International Association of Computer Science and Information Technologies, International Associations of Engineering, and Indian Society of Electronic and Communication Engineering, and ORCID. His area of interest include communication systems, signals, and image processing, machine learning, and virtual realities. Now, please, I am inviting Professor K. Martin. You can start your lecture.
Thank you, Professor, for. Can you hear my voice, Professor? Can you hear my voice and video?
Yes, sir.
Yes. Thank you. Thanks for your detailed introduction about me. And I am happy to deliver the keynote speaking in this reputed conference. I will share my screen, sir. Sir, can you be able to see my screen?
Yes, sir.
Yes.
Yes, sir.
Good morning to all. I am happy to give my keynote speak on the topic computer vision algorithm based gesture technology for virtual reality application in this reputed international conference on computational technology and intelligent missions 2020. And I am thanked to Professor Dr. Meher Chand and the management for Baba Farid College, Punjab, for inviting me to deliver the keynote, and also and previous keynote speaker, Professor Satya Singh, given a detailed topic on optimization technique. So I am thankful to that professor in detail, since I am also working on that with hybrid techniques in machine learning algorithm. So in my talk, I'm not going to give detailed on optimization techniques, since Professor Satya Singh has been given a detailed on it. So I bred the machine learnings in that technique for a reality application. So for social needs. So thank you, Professor, for giving a detailed talk, Satya Singh.
Welcome, sir.
Thank you. And myself, Martin Sagayam, working as assistant professor in the Institute of Karunia University. This is my Karunia University place. It is a pleasure to have, and I'm inviting you in future. Everyone can visit my place. It is cool, and there are many spots to see. It is established in 1986. It is NB accredited and NAC accredited one of grade, and established of R&D centers, NRF ranking of 72 and university ranking of 92. So this short introduction, I am going to skip to my keynote speaking. I am going to give only the topic on gesture technology. Nowadays, we are talking about gesture technologies. How this gesture technology can be involved with computer vision algorithm. Actually, this gesture technology is one of the topic in computer science and language technology, with the goal of interpreting human gestures via mathematical algorithms. Gestures can originate from any bodily motions or state, but commonly originate from the face or hand. The current research focus in the field include emotion recognition from the face and hand gesture recognitions. The user can uses the simple gestures to control or interact with the device without physically touching them. And many approaches have been made using cameras and computer vision algorithm to interpret a sign language. However, the identification and recognition of postures, jains, proxemics, and human behavior is also the subject of gesture recognition technique. The gesture recognition can be seen as a way for computers to begin to understand human body language, thus building a richer bridge between the machine and the human than the primitive text user interface, or even the graphical user interface, which still limits the majority of input to keyboard and interact naturally without any physical contact with the mechanical devices. Using the concept of gesture recognition is possible to point this point will move accordingly. This could make a conventional input on device can even redundant. Actually, what I'm conveying is that in currently we are having touch technology and remote technology. So in future, those technologies going to be convert into gesture technology. There is no physical contact between the human and the machine. So that is the main problem I am focusing in this keynote speaking. It can be used in all platforms, all field like virtual gaming, medical, automobile, etc., etc. So these are the recently. I hope I can. My screen is seeing with animation. So this is one of the technology held in last that is 2 years back in BMW car. Through gesture technology, they have developed the audio systems. As Satya Singh sir told about some mathematical approach on some meta heuristic, some optimization techniques he told. Actually, in machine learning algorithm, what is the thing is that it should recognize something. So in machines, there are some acquisition devices like sensors and transducer, and then electrodes will be there. That should be that should be sensed by the human actions. So such as gestures, voice, face, etc., etc. So in this system, what the BMW company has been developed is that they have used some actions for accepting a call, reject a call, turn up the volume up and down, and change the rear view of camera and the navigational view. So that has been developed using a simple hand gesture technology. Similarly, in the year 2014, one band, that is the band called as Mayo band, Mayo gesture band. So in this band, it will sense the neural activity of the hand without using the new remote. Okay, without using the remote, the quadcopter has been controlled through the simple hand gesture recognition. So and show some slides with some examples, so then you can clearly picturize, and I will tell about some algorithms after that. So you can see this picture. It is some virtual concept to be delivered for electric circuit analysis. It has been done with the virtual glass, virtual Google Glass or Microsoft Glass. There are many companies or nowadays manufacturing for the virtual glass. So it delivers the content in real world, that is virtual real world. The concept also delivered to the students or audience in clear without going with the theoretical. Okay, so they can experience how the practical effect of that thing. So even we are talking about the machine learning, when we convert into the real product, it have many troubleshoots are there to develop such a product. So please see here, it is a one virtual game related to football. So the two that is the two opponent teams are playing really, and they are went to that platform, football platform, and they are playing, and they also have the experience that they are playing in that ground. They feel how in that ground it is a glass of 360-degree experience, and they have they will get relaxed due to these type of playing effect. Please see, this is related to the educational field. So here also the machine learning plays a major role for virtual reality. So they have developed a model of human skeletal system, and they can study the anatomy of the human body through the virtual glass. Similarly, this is the educational content related to the physics. If this type of thing has been adopted in future in schools, it is really helpful for the students, and they also get the content in quick, and they understand, everyone can understand the concept. So this is some application related to the medical field. Yeah. So in all the concepts, you can see there have the simple hand gestures. So to develop the simple hand gesture, some mathematical modeling is required. So, I have took some 127 reputed articles. Through that, I have framed out my keynote speaking slide. So these are the some literatures. I'm not going to focus on more literatures. So please look into some literatures focused on hidden Markov model approaches. Okay, hidden Markov model approaches, and then deep convolutional neural network. So from this, I am going to give some inference on my literatures. Okay, so it is lagging of the robust based on typical part of the input constraint consistent, and it is robustness with the rigid condition implementation. It does not work for a large postures and gestures. The complexity computationally expensive, and track only the open end, and it requires the more training process, Actually, why I'm telling more training process, if I am train a machine, it required more training. So the machine is like a small kid. I have to train with a machine learning through all type of database, which is available, a real database or else some synthetic database. Using that, I have to compute more and I have to give more training for to recognized by that particular system. So these are the fundamental basic problems I focused. There are many problems are there in and around the world, but I have focused for gesture recognition these problems. So the problem statement, what I am going to define through my literature is that the conventional hand gesture is still tougher with a low accuracy and recognition rate, and my scope for improvement in conventional hand gesture recognition system. So this is my objective. So in my objective, I'm going to talk about one of the mathematical stochastic approach called hidden Markov model. In hidden Markov model, I'm going to talk about 1D, 2D, HMM, and what is the problem in 1D, 2D HMM, how to solve the training process with the help of the behavioral approaches or natural inspired algorithm or bio inspired algorithm. As sir told, Satya Singh sir told about the some that is ant colony algorithm, etc., etc. So in this approach, I have used artificial bee colony approach for to optimize the training process in my algorithm. Okay, so this is the flow of my work. So it contains the input database, pre-processing, feature extraction, and the classification parts will be there. So I have categorized the classification part by comparing 1D hidden Markov model approach classification, 2D hidden Markov model based classification, and 1D HMM with the ABC optimization and 2D HMM with optimization. Then I will focus on the some performance matrices. So the first module, please look. These are the some database. Some database here I have given some sample database which is taken from Cambridge University, and some database I am having in real also that I am working currently. Later I will show those things also. It is this gestures can be used for virtual gaming applications or it can be used for some teaching learning process also. So this is the sample database. So after that, I have done some pre-processing. So the pre-processing is nothing but to transform one data into another data by filtering out some unwanted frequency component. Okay. So and removing the noise effect. And then I have used the non-local mean filtering. In non-local mean filtering, it have the observed value from the given image is nothing but the resultant value of true value and a noise. So my objective is that to remove the noise. Okay, so even I am adding some noise in this equation, I have to filter out by using the non-local mean filter. So this is the procedure. I'm not going to talk about the detail in this thing. So I will show how it has been done. Okay, so please see the image of the hands. So you can have some intensity level in the good intensity level in my images. So there some additive noise like Gaussian noise or else some white noise will be there. That noise has been filtered out by using the non-local mean filter. As I shown the equation, n of I is the noise factor. That noise factor has been eliminated. So by checking the mean square error, please see the value of mean square error and the PSNR. It is removed and the factor has been given here. The value how much it is removed from that given source image I have shown. These are some values. Then after I will feed, I will go for the feature extraction with the histogram oriented gradient features. So it is used to reduce the dimensionality of the image. So actually, basically, why this for feature extraction technique is going means when I am going for real hardware. So all images cannot be fed to the chip or the memory unit. It will be hang while it is processing. So I have to take the important feature from the given input source data. So in this work, I am concentrated on the histogram features by using this histogram of various gradient features. So this is the specification, that is cell size of my work is 8 cross 8. Block overlap is 1 cross 1 and the number of bin is 9. So these dotted values, okay, it is orienting in different directions. Okay, so this particular thing alone I am going to take, since the hand gesture when I am talking, it is a natural language. So I cannot tell what action it is giving. So we human only tells that this is for some action, this that is for another action, like that we have to tells to the system through the programming, so after completing my feature extraction, I will feed to the classifier. My objective is to do the experiment with the classification, what are the different hand gestures are there. So I will talk about what is meant by hidden Markov model. It is a predictive analysis and it is one of the stochastic mathematical approach. So this algorithm is used to train the system effectively. But when we see about the computational complexity, it is more. Okay, it is more. Why means the number of states in my system is that is 3-level state. Okay, 3-level state. So totally, there are many states will be there. When the signal is feeding from one state to another state, some recursiveness operation will be done. So when some recursiveness is going on, some feedbacking will be occur, and that leads to lot of power constraint in when goes to the reality systems, and this may affect the computational computation. So I took that as my problem, and in the training process, I have used the optimization algorithm. So I will tell in the forthcoming slide about how that is how the that is optimization algorithm has been done instead of the Baum-Welch algorithm. Actually, in hidden Markov model, okay, so first it will define the model parameter like transition probability, output probability, initial probability. Then it will do the sum of all transition state probability. For training, the Baum-Welch algorithm has been used. So in the transition probability of P of Q by lambda is not equal to 0. This condition has been given for forward approach and backward approach. And for testing, Viterbi algorithm has been used. Okay, so at last we get P of Q by lambda, that is the maximum probability of occurrence. Through that maximum probability of occurrence, we can predict what type of hand gestures or we get in the system. So this is the experimental results for that is for training set and the testing set. So in each classes, I took 60 images, 60 images of frames for all type of hand gestures. So for training set and testing set, I have given like that. And through the confusion matrix of the hidden Markov model approach, the predicted class and the actual class has been given through my experimental results. So please see the diagonal value from this gesture actions. You can see so maximum value has been attained, and where the values at the row wise and the column wise rather than the diagonal, some values are there, that is all the false rate values. So that false rate values may lead to some wrong predictions. Okay, so these are the performance matrices I taken like sensitivity, specificity, accuracy, positive predicted value, and positive likelihood ratio. So this is my performance estimation, true positive, true negative, false positive, false negative for all on gestures from the experimentations. And this is without optimization. That is 1D HMM without optimization. So my performance matrices for accuracy, sensitivity, specificity has been attained like this. Please look into this value. It is somewhat less. When I'm going for the 2D HMM, actually, what is the difference of 1D and 2D is that next I'm going for 2D only. So it is an extension of 1D HMM and it have some super state. Okay, so usually my data will be in 2D form. If I convert 2D into 1D, it will suffer with some information. So it may lead to some wrong predictions also in 1D. So that I am taking the 2D information to my system of hidden Markov model. So it has some super state. So it is somewhat complex than the 1D HMM. Please see the architecture of 2D HMM. It is somewhat complex than the 2D HMM. Computational complexity is also high in the case of 2D HMM. So in this way only my state sequence for all hand gestures will go. So this is my state diagram for the hidden Markov model. So it will jump from one state to another state. Some recursiveness also comes. So due to the some recursiveness, that is it may lead to the delay in recognition. Okay. So this is the Viterbi algorithm, as I told already. It is for the testing purpose, and this state sequence analysis is also the another new algorithm to sequencing all gestures with respect to the each action. So according to the Q. Okay. So at last it returns the probability of occurrence, that is P of S x comma y of O. It is the observation. So when I am deal with 2D HMM, okay, 2D HMM, please see the diagonal value for this predicted class and accuracy factor. It is somewhat improved, okay, than the 1D HMM, which means that there that is, as I told, 1D HMM as some conversion from 2D data. So some true rate value is also there in the case of the 1D HMM. Whereas in 2D HMM, you can see some improvement. That is the diagonal value you got very high. It is the performance measures from the 2D HMM. So these are the matrices I have calculated. So it is somewhat improved. Okay, it is somewhat improved in the case of 1D HMM without optimization. But my objective is that to remove the recursiveness. So in order to remove the recursiveness, I am going with that is an artificial bee colony algorithm. Professor Satya Singh has been explained in detail about some concept related to the optimization. The same concept will be in the artificial bee colony also. It have the three type of bees: haploid bee, non-super bee, and a spouse bee. How it has been incorporate in the mechanism of hidden Markov model state diagram. Okay, so please see that is when the bees are moving from one point to another point, it will smell where the more smell effect will come. There only the bees will be like antidote. So there is no there is no that is no bees are going unwanted direction. Only the where the food is available, there only the bees are moving. Okay, so this concept is incorporating in the case of the hidden Markov model in the training process instead of bomb wells algorithm. Okay, so first initializing the all way to small random value for all states. Choose the random state as a starting node, calculating the maximum likelihood value, and use artificial bee colony to collect neighboring nodes, updating the winning nodes and selected the neighbor nodes. Repeat the steps 2 to 5 for a given number of iterations. Still, we will get the best fitness function. This 2 to 5 fifth step will be repeat until we getting the best fitness function. So when I'm hybriding the concept with the Adam Markov model, okay, the fitness function has been given like this: 1 divided by minus h of lambda of x of I. This provides that is maximum probability of occurrence for the state sequence of hidden Markov model approach. Please see this value in the diagonal, the for predicted class in the actual class. It is somewhat more than 1D and 2D without optimization. So, which means that we're getting more true rate values we are attaining. And similarly, I am going for the 2D approach with the ABC. Please see, I got the maximum occurrence of the true rate value in my predicted class and the actual class of hand gesture data. So these are the performance matrices. So I will show my performance in the table. Yeah, then you can, yeah, this is my comparative chart for only 2D HMM with Viterbi and 2D HMM with SSA. SSA is nothing but state sequence analysis. And 2D HMM with Viterbi and SSA with optimization, that is artificial bee colony approach. So please see the value. I got the accuracy of 96%. Okay, where these values are very less. I got into the HMM 96, but in this case also the computational complexity is more. But now I'm doing research on how to remove the computational complexity in real time when I'm going for the real system. Okay, but even then the sensitivity, specificity, PPV and PLR is good, but still when we go for the real product, okay, it have some trade-off. So we have to maintain that standard for coming that product to the market. So that I am really focusing on. So this is the approaches with the previous machine learning algorithms. So in 2D HMM with the ABC got the maximum accuracy rate. So I got the good recognition rate when I'm going for the real-time systems. So this is my conclusion of my keynote speaking. So I says that 2D HMM with optimization provides the good performance rate rather than the other approaches. So in future, I am working on with some deep learning algorithms for this type of gesture technology, and for making the real time system for social benefits. So these are the references, and these are the books published by using these type of techniques. So one of the book titled Deep Learning Strategies for Security System in Wireless Sensor Network. It is published in IGA Global. It is a focused book. And another two books are related to some bio-inspired meta-heuristic approach for real-time applications like fingerprint recognition and virtual control wheelchairs in good publishers. So thank you very much for giving this wonderful opportunity for me. And thank to Professor Megachand and all of the team members of Baba Farid College. Thank you very much. So this is my contact detail.
Thank you, Dr. K. Martins.
Yeah.
Uh, I sincerely thanks Professor S.V. Singh and Professor K. Martin for giving their invited talks very nicely, and their lecture will be very useful for the students. Now, we will start paper presentations, and first presentation of Dr. Kawaljeet Motia, and the title of his research paper, Challenges and Opportunities in the Development of Shape Memory Allies, a Comprehensive Review. Professor Kawaljeet Motia, now you can start your presentation. Hello. Hello. Professor Kawaljeet. Hello. Okay. I'm inviting for the next presentation for the Dr. Mihir Chand. His title for the presentation is a merapodic solution of the certain types of the nonlinear differential monomials.
Hello.
Hello.
Sir, my name is Shiva Buzurg. On behalf of Sir, I will be presenting the paper. Shall I go ahead?
Okay. Okay. Yes.
Can you allow me to share the screen? Can you see my screen?
Yes.
So, hello everyone. My name is myself Shiba Kausar Buzurg. I'm a research scholar in the Department of Mathematics, Presidency University, Bangalore. I'm working under the guidance of Dr. Rajeshwari S, Assistant Professor, Department of Mathematics, Presidency University, Bangalore. Topic from my presentation is meromorphic solutions of certain type of nonlinear difference monomials. So abstract of my paper here is we consider meromorphic solutions to general nonlinear difference monomials of this type. Okay, so we are considering the difference monomials of this type, that is m of z comma f is plus l of zf is equal to summation of gamma j e to the power of var pi j z, where j is running from 1 to r, where this m of zf is equal to f to the power of d1, f to the power of d2, and so on up to f to the power of dj of z plus tau j, where d1, d2, d3, so on up to dj, this belongs to capital N. This m of zf, this is my non-linear difference monomial, what we are considering in this equation. And here L of ZF is nothing but summation of Tj f to the power of Nj, Z plus Xij, where j is running from 1 to s. And this 1 is less than n1 is less than n2, so on up to ns. And this gamma j here, this j is running from 1 to r. These are non-vanishing constants, and tj of z is where j is running from 1 to s, are non-vanishing small functions. If the equation admits a transcendental monomorphic solution f of finite order satisfying where pi of f is less than gamma of sigma of f, then representation of f and gamma of I where pi of j can be obtained. So, an introduction to the paper is in this article, we have considered a linear delay differential equation of this type, that is x dash of t plus summation of pn of t, x of t minus tau n, and n is running from 1 to k is equal to 0. And here pn is nothing but it lies in this interval, and tau n is greater than or equal to 0. That means it's positive, and n is running from 1 to k. We expect that the reader is very familiar with the standard symbols and basic consequences of Nevelina theory. That is, some of them we consider as a order of x that is defined by sigma of rho of x, which is equal to limit of supremum of log of t of Rx divided by log R, where R tends to infinity. And the other one is hyper order defined by row 2 of f is equal to limit of supreme of log of t Rx divided by log R as R tends to infinity. Here we consider, as we have said in the abstract, the first introduction part. So here we are considering this kind of non-linear difference monomial, where this m of zf is equal to f to the power of d1, f to the power of d2, so on up to f to the power of dj, z plus tau j. And here this d1, d2, dt, so on up to dj, and this belongs to n, and m or f are this is the non-linear difference monomial. And first we treat the simpler equation as follows, that is this is the equation what we have considered, and we have also mentioned what is LF. So this is nothing but the value of LF what we have considered here. And here is that the main result what we have considered is this one, the theorem 1.1. This theorem 1.1 is being proved in the paper, and this is the main result what we have considering. So we are assuming that equation 2. So this equation 2 admits a transcendental meromorphic solution f of finite order such that var pi of f is less than sigma of f, and var pi of 1 by f is less than sigma of f. Then we have three conditions to be proved. That is, first one is R is equal to s plus 1, and second one is mod of var pi of j, where j is running from 1 to s plus 1, are different from each other. So namely, there exists a rearrangement with say I1, I2, so on up to is plus 1 of where this 1, 2, 3, so on up to s plus 1. We are considering that. So such that var pi of I1 less than var pi of I2 mod of, so this is less than mod of var pi of is plus 1. So third condition is f is unique. More precisely, f can be represented as f of z is equal to gamma of I2 divided by T1 e to the power of n1 xi 1 var pi I1 to the power of 1 divided by n1 e to the power of var pi I1 of z. So here this is a continuation of theorem 1.1. Here we are considering, here in this equation we have Tj, and also here we are considering, so this T1, T2, so on up to, it goes up to Tj. So here Tj is, here j is lies between 1 to s, gamma j, here j is lies between 1 to s plus 1, and here j lies between 1 to j plus 1 lies here, in this j lies between 1 to s. So this satisfy var pi of ij plus 1 is equal to nj var pi of I1, and this as we are considering the product, so the product of this is being considered as here we get the result as var pi of I1 to the power of dj e to the power of beta tau j is equal to sigma of I1, where gamma of I1 divided by T1 e to the power of n1 xi1 var pi of I1 to the power of minus n1, where this beta is non-zero constant, and we get this result, that is gamma of I1 divided by T1 e to the power of n1 xi1 var pi I1 to the power of 1 divided by n1. This is equal to here after this we get n2, n3, and so on. So lastly we get gamma of is1 divided by ts e to the power of ns xi s var pi of I1 to the power of 1 divided by s. So 1 divided by ns. So here consider the case when this tj, where j lies between 1 to s, are small, and namely we treat this equation as we have considered there. This is L of zf. This is one more result what we have proved in the paper, that is we assume that equation 3 is this admits transcendental monomorphic solution f of finite order such that var pi of f is less than sigma of f, and var pi of 1 by f, here this is less than f. Then we these three results, the first one is if R is less than S plus 1. The second one is mod of pi of j, where j lies between 1 to S plus 1, are different from each other. Namely, there exists a rearrangement, say I1, I2, so on up to IS plus 1 of this lies between 1 and this goes up to S plus 1, such that pi of I1 is less than so on up to mod of pi of S plus 1. And that this is the third condition, that is Tj of Z have the same zeros and the same poles, each without any counting multiplicities. And we consider to write Tj of Z is equal to Vj to the power of Nj of Z, where Vj of Z are certain uh, are more of certain meromorphic functions. So this is the continuation of that. So this is the fourth point. The fourth point is if f is unique, more precisely, f can be represented as f of z is equal to gamma of I2 divided by T1 e to the power of n1 xi1 over pi of I1 to the power of minus 1 divided by n1 e to the power of pi of I1 of z. And here Tj, gamma j, and pi of ij plus 1 are represented in this way, such that pi of ij plus 1 is equal to nj pi of I1. Here, as we are considering the sum, so we are gonna get summation of pi of I1 dj e to the power of delta tau j equal to gamma of I1 of gamma of I2 divided by T1 e to the power of n1 xi1 pi of I1 to the power of minus 1 divided by n1, where delta is a non-zero constant, and we get the result as gamma of I2 divided by T1 e to the power of n1 xi1 pi of I1 to the power of 1 divided by n1, so on, is equal to of is plus 1 divided by, here we get tq e to the power of ns xi j pi of I1 to the power of 1 divided by ns. So here, to prove our results, we need some main results, that is main lemmas, what we have considered in the paper. The here
time नहीं over हो जाता sir.
following lemma we see in the reference one
time नहीं over हो जाता मैंने लगा.
is called as lemma for logarithmic derivative. The first lemma is we consider is if we let f of z is a meromorphic function, then we have
Hello.
m
Hello,
of
Professor. Hello. Please conclude your work.
r f to the power of this is the
Hello.
derivative. Yes.
Hello, Professor. Please conclude your work. Time is your over.
These are the lemmas what we have used. This is second lemma. So these are some work which I have also used in the references. I mean, here this is the final. I mean, main thing what we have proved in this paper is this theorem, theorem 1.1 and theorem 1.2. As you can see, these are the some results what we have considered to prove the lemmas. And these are some references what we have used. Opportunity to present my paper. Thank you so much.
Hello. Hello.
I can hear you. Can you hear me?
Yes. Ma'am, please tell me what is the small function?
Function is that is sigma of z, what we have used in the function here.
Okay. And how to analysis convergence of such function? Hello. 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 Hello.
maybe some internet issue, I think so. We will
Yes.
move ahead.
Okay. I'm inviting for next talk Abdul Rizak. His topic is a numerical investigation of potential numbers, effects on the heat transfer, characteristics of a nuclear fuel elements. Hello, Abdul Rizak. Hello, can you hear me? Abdul Rizak. Next presentation is a Nitika Kapoor. Nitika Kapoor. Hello.
I think she is not there.
Okay.
Is there anybody who is willing to present his research paper? If there is anybody who is willing to present their research paper, can contact Dr. Naren.
And Professor Jasprit Kaur. Can you hear me? Miss Indumati.
Dr. Meerchand. Professor Meerchand, Shefali madam.
Hello, Dr. Nindra. Please announce the next participant. UID is please note the UIDs. UID is 214 272 253. If anyone is present here, please ask them.
Anybody with ID 214, 272, 253 can present their papers right now. I think Professor Meerchand, nobody is here out of these guys.
Dear Professor, Jasprit Kaur is trying to correct us.
Okay, okay.
Yes, sir.
Good.
I think there is some network from other side.
Okay, okay.
Hello.
Hello, Jasprit Kaur.
Hello, Jasprit Kaur. Hello, hello.
Dear delegates, anyone is present here, please raise your hand so that we can announce your paper.
Hello, Jaspreet.
Hello.
Jaspreet. Yes, please. You
Hello.
can start. Yes, please. You can start.
Sir, my screen is not sharing.
Okay, I give
I
permission.
share.
Yes. Yes, please. Now you can share your screen.
Uh, so there is a message on. So there is a message on my computer. Zoom is unable to detect a camera.
Jaspreet, please share your desktop. Jaspreet, please unmute yourself and start.
Hello, Jaspreet. Hello.
I think there is a network problem. Dear participant, if there is any more delegate who is willing to present his paper, I am announcing their paper ID. If anyone is present here, paper ID is 253. Next is 272, 214, 218, 278. If anyone is present here, please raise your hand. If anyone is present here, please unmute yourself and you can announce. 257. Mr. Balwant Singh, paper ID is 257.
Yes, sir.
Yeah, are you present? Yeah.
Yes, sir. Good morning, sir.
Good morning. Very good morning. And I permit you to share your desktop. Just please
Okay,
come.
sir. Okay,
Yeah.
sir. I am sharing. Yeah.
Mr. Balwant, you can share your desktop.
Yeah, sure. I am sharing. Wait. So my screen is visible.
Yes.
Yes.
Okay, sir. Okay, so my topic is on the investigation of rheological properties of copper. That is a reinforced PA6 composites for 3D printing applications. So actually, that is a fused deposition modeling is like that is my main topics which I covered in this paper. That is introduction, literature view, experimentation work which I did, and resultant discussions and references on which I collect the data, right? And first of all, what is like introduction about that. So fused deposition modeling is like a most, you can say the most efficient and frequently used method for the development of the functional prototypes and rapid tooling, customized products. So actually in the FDM process, you can say the polymer and the polymer composites are passed through a nozzle in which heaters are provided to melt the feedstock filament. So thus it is like obligatory to maintain the melt flow index of the filament in according with the size and speed of the nozzle of that. So the polymer materials used as a feed stock filament have defined that metal melt flow index of that, but the effect of metal reinforcements that change the rheological properties that is not established, right? So this, which I study experimental work of this, that actually focus on the calculation and measurement of the melt flow rate of the copper reinforced PA6 thermoplastic material. So the melt flow rate has been checked for different concentration ratios. That is which I checked in further. I will show you. That is like 1%, 1.5%, 2.5%, and 5%. So the basics on the which the literature view, which I get the all the things that first of all, like Braille et al. Performed an experiment that to find out the best probability method for manufacturing of a complex shapes of different automobiles part. So it was concluded that FDM method is the best way to produce a complex shapes by using a glass fiber reinforced plastic composites. Same as like Rossi et al. Highlighted the points regarding the additive manufacturing, which helps in producing 3D printing parts with a high geometrical intricacy at a no additional cost. So like a shorter lead times, lesser weight we get, and appropriateness for customization just as a low volume production of even you can a single parts you can manufacture according to your requirements. So it has been analyzed that the properties of FDM based composites is exceptionally dependent to the fabrication direction and porosity of the composites. Same other researchers are doing like a performed an experiment with the polyactic composite material. The silver particles were added to the polymer in a different weight ratios, in particular like 1%, 2%, up to 5%. So it depend upon the conditions they are like doing the experiments, right? So it directly affects the nozzle of the 3D printer. So same some these are the some reviews which I did. Like first one, that is a polymer name is ABS and reinforcement plastic fiber they are using, and the technique which are using, that is FDM. So finding is less layer thickness, negative airbag, lesser raster widths, and increasing the raster angle improve the tensile strength of the composites. So findings are mostly used in aerospace industry, right? Same as like there are other reviews done by the different researchers PVC polyvinyl chloride as a polymer they are using with the reinforcement is Malaysian bamboo fiber, and the techniques are FDM only. And the bamboo particles has continuously enhanced the modulus of elasticity of the product. It increases the water absorption power and strength of the impact log sustainability at there. Mostly used in aerospace industry. Same like as this nylon 6 are using with iron as an reinforcement, and it like a higher the extrusion route temperature obtained, higher the melt flow index we get. So MFI of iron and nylon 6 composite same as like a MFI of virgin ABS, higher the nylon 6, higher the fluidity of the composite that is used in automobile industry. So there are various reviews that already done by the different researchers, near about 14 reviews which I did. So in my experimentation work, it has been noticed that the extensive research has been done on the various FDM process parameters, such are like infill percentage, number of shells, layer height, infill style, layer thickness, but a very limited search has been done on the characteristics of the flow of composite material. So hence, here I am doing in the study, like in the aim of using copper and PSX, that is to increase the thermal conductivity of the material, which can be widely used in automobile industry in future. So the characteristics of the material that used flow, also known as a rheological properties, that can be checked with the MFI, right? And the MFI tests the weight proportion of the material as it passes through a nozzle within a given time at a definite temperature range, that is near about 230 degrees Celsius for a nylon 6. And the force is applied with the help of weight provided on the like you can say on the head of the ram. The aim of the MFI test is important because before feeding the composite and the material in the FDM machine, it is like we have to check the flow rate of the particular composite, so that the composite can perfectly flow through the nozzle. So it also ensures that any choking in the nozzle or uncontrolled flow of the composite through the nozzle does not take place. So my that experimentation which I done, that basically you can say the to check the flow rate of the different composites of a nylon 6 with the copper particles in the MFI tester. So where I am using the MFI tester first, that is a melt flow index, that is a basic which I am using in my experimental work. It is also called a melt flow rate, which actually calculates the flow rate of the polymers in the weight proportion within given period of time and temperature. So there is only like one particular standard which has been used for a MFI process, that is ASTM D1238 and ISO 1133. So first of all, in this process, samples of the polymers or polymer composites weighing 5 grams are prepared. So in the case when they are taking two materials, one act as a matrix and other act as a reinforcement. So then the reinforcement is mixed in a different weight ratios and sample of 5 grams are prepared for each composition. So after finalizing the sample, the weight 5 grams pass it through the heaters above the melting point and flow through the nozzle with the help of ram weight that varies from 2.16 kg to 5 kg. That we have to do within 10 minutes, right? So afterwards, weight of the sample is determined for 10-minute duration, which calculates the melt flow rate. So this method is one of the most popular method that is used by the different industries while analyzing the exact composition if the material is required for the particular FDM machine. And that is the procedure of experiment which I did in the present study. The melt flow rate for a different percentage proportions of copper and PA6, that nylon 6, was analyzed with the help of MFI. So the weighing machine was used to take the different weight of the copper powder and PA6 according to the percentage required of a particular material. That is already I done in this. That is 0% copper and 100% nylon is there. Temperature is 230 degrees Celsius. RAM weight is 2.16 kg. So first reading which I get 4.781. Second reading that is 4.961 gram per 10 minute, and third reading was 4.413. So the mean reading is this one. Same as like a 1% copper and 99% nylon 6. That same with 230 degrees centigrade temperature with the weight of 2.16 kg. These readings I got, right? And same for third, 1.5% copper and 98.5% nylon 6. These results I got. And 2.5% copper, 97.5% nylon. This result I got from there. And 5% copper, 95% nylon. This results which I got from there. So the temperature of the melt flow indexes was controlled at 230 degrees centigrade, and the weight was provided over, that is 2.16 kg. That is without any variation. So then the melt flow rate of different compositions was checked according to the time. that which I got the result in this table, which I already written it there, right? So that is like a overall. After that, when I got the material from there, I checked the results and discussions about that. So the material which is extruded out from the die of the melt flow tester was weighed with the help of weighing machine and repeat the process 3 times for a particular percentage of the composite. So here in the like which I got in this material. That the experiments like at 1.5%, 2.5%, 5% copper particles was conducted, and results are which I show in the last table. So the slight variation in the melt flow index has been noticed for each reading at a constant copper reinforcement. So it has been observed from the all above calculations that as the proportion of the copper reinforced particles were increasing in the nylon 6 matrix particles, the fluidity of the composite materials is reduced, right? As we see in this table. So when we are increasing the copper particles, the fluidity of the material is decreasing continuously when we are increasing the copper particles in the nylon 6. So the test of fluidity was done up to the 5% only of the copper as a reinforced material addition to a nylon 6 matrix material, and minimum MFI of the value that which we got here, that is 0.746 gram per 10 minute, that was observed from this reading. And the conclusion is that FDM is established a 3D printing technology used for development of a new products, rapid tools and functional prototypes. So the study has been performed to evaluate the suitability of copper powder as a reinforcement of PA6 thermoplastic material as a feedstock filament for 3D printing applications. So the rheological properties of the copper powder reinforced nylon 6 material has been measured in terms of MFI value. So the MFI has been tested in a different compositions of copper powder under the controlled experimental conditions. It has been concluded that the copper reinforcement significantly reduced the MFI value of the nylon 6 material. So as the copper concentration is increased, the MFI is reduced due to increase in particle size in that. So that is all from my side. Thanks to all of you.
Thank you, Balwan Singh.
Thank you, sir.
Please, if anybody asks to any question, you can. Okay. Just I have one question for you. Please let me know what is the application use of your work.
So actually, application.
Hello?
Yes, sir. I am audible.
Yes. Yes, sir.
Actually, sir, applications basically you can say that if we are there are some particles some are components in our automobile industry in which we are using the supply of electricity, or there are some components which are spreading the heat. So when we using the that kind of components, we need a copper at there because copper have a high melting point. So that's why we are trying to mix the copper with the nylon 6 particle, so we get a proper results of that. Like you can say that where the heat is also there, and we can want that our component can't
cost effective.
Hello. 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 Hello.
Ji, sir.
Please, Professor Singh wants any questions.
I was saying, Balwant, does it have an economic cost?
Yes.
If you are using copper.
Yes.
Sir, I am not actually getting you. Can you repeat the question, please?
I am asking whether it is cost-effective composite.
Sir, actually, that nylon 6 actually use where we need a tougher and higher tensile strength and good elasticity and lustrous. So the best quality of nylon 6 is that it is chemically resistive and abrasion resistive and wrinkle proof. So that's why I am using the nylon 6 with it. So due to the nylon 6 properties are widely used in making gears, bearings in automobile industry, most of them, like strings for a musical instruments also. So as we see that which are gears are manufactured with the nylon 6 material. So in aerospace and automotive industry. So we also know that when the gears are like moving with each other, there is a friction between that. So when there is a friction, we need a higher melting point material. So that's why I am trying to add the copper material in that so that we get the results.
Okay, okay.
Okay. Thank you, Balwant.
Okay, sir.
Thank you. Nice. No.
Thank you. Thank you, sir.
Any another one want to present your work? Daljit Kaur. बार बार बंद क्यों हो रहा मेरे वाले में सर नेटवर्क की हो रहा है बार बार आप
Dr. Narendra is asking whether
253 Daljit Kaur is present here.
somebody is interested in presenting his work, or the session should be closed.
Dear delegates, if anyone is present here, please announce your name by unmute yourself. If anyone is present here,
If anybody is interested to present his work, he or she can present in this session. Professor Mayor, I think nobody is there.
Dear Professor Martin, I ask you please conclude the session.
Yes, sir. Yes, sir.
I think you should ask Madam Shifali to close the session.
Sir, can you hear my voice? Can you hear my voice, sir?
Yes, yes.
Yes, sir.
Yes. I thank all the participants who gave this research presentation in this reputed international conference on computational techniques and intelligent mission 2020. Once again, I thank you to the management of Baba Farid College, Punjab, for this nice opportunity for me to connect in this conference as a keynote speaker and a session chair. And I also personally thank to Professor Meher Chand for his kindness and the invitation. Also, I would collaborate in future programs and research. I thank to Professor Narendra Singh. Sir also joined in this session. He done a great job in this conference, and he done coordinated very well. And also, I thank to Professor Satya Singh, sir, has gave the nice keynote speak on optimization technique. This topic is somewhat related to my research since I am also working on artificial intelligence. In future, I may contact you, sir, for future
Thank you, sir.
and support. So once again, I thank you to all organizers and the team members of Baba Farid College for conducting this nice program. Through that, we have connected. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Thank you.